October 2022, and we are here in the study and we are testing drive or disk D02, which is a Mitsubishi Mitsubishi MR535. Now this is a 40 megabyte hard drive from the late 80s, and we've attached it to our Kremenko system, and you see the end of the test. I don't want to prejudge the results, so we're going to do a disk info of STD31 to show you the actual partition table that's written to the front of the disk. So it is October the 4th, that's correct. This is in terms of data, a 5-head disk with 977 cylinders, of which we are using between 1 and 972 for the data partition, which is 48 megabytes in size. Track 0 or cylinder 0 is not used for anything except administration, and cylinders 973, 974, 975, 976, which is the start location of the alternate track, is 973. They are used for the alternate track table, which has been populated before this video started with these bad cylinders and heads. So what this is saying is that cylinder 34 head 1 is mapped to cylinder 973 head 0, and it continues with all of these alternative tracks. So what we're going to try now is we're going to read the disk and include the alternate track table. So we're going to do a read all, include the alternate track table, and we're going to do it on STD31, which is the entire disk. You see it says /dev/STD31 here. Okay, let's go. With the magical power of editing, I will speed up this process, otherwise we will all fall asleep. Okay, back in a minute. Okay, Dari, as expected, we have got to the end of the read all and there are no errors. And why is that? That's because we've read the whole disk, but we've included the alternate track table. So in other words, cylinder 34, head 1, which we know is an error, was never read, because it was instead replaced by cylinder 973, head 0. Now, I can prove that there are things wrong with these cylinders, 34, 35, 36, etc. If I do a read all, I can't remember the syntax, so we're going to read all. So we're going to read all. We're not going to use the -a command, so we're not going to look at the alternate track table for guidance. And we're going to start at cylinder, let's call it 30, and we're going to finish at 40, for example. And it is of STD31. So I'm expecting to get errors now because we were going to read the actual cylinders between 30 and 40. Let's go. So you can see that there are indeed these surface errors, which is what I had found earlier, and they have been incorporated into this table here. Let me just show the table again. Disk info STD31. So they've been incorporated into this table. Right, so I think that's about it. Just for completeness, I could try and create a file system onto this hard drive. Let's go to full Monty, and so we've got a single partition 0 starting at 1 ending at 972, So I can say make a file system of std0. Now this will make a Unix or Linux, if you're talking 2022 style file system. You can hear the seeking. It's quite a smooth drive, so you can't really hear the seeking very clearly. But we are creating an inode structure on the hard drive, which is a directory structure into which directories or files or devices can be placed. Now, there are various parameters with the makfs make file system command. So you can say how large should the inode table be. I've just gone for the default. So I think for a drive of this size, it's probably going to generate thousands of files. Sorry, a directory, an inode table that could accommodate thousands of files, perhaps 10,000 files. And just to be clear, we booted from the floppy drive, so there are no dependencies on any of the hard drives in the system. You can only have two on the Kremenko ST-DC disk controller anyway. So at the end of this we'll have a Chromix formatted file system which we can then mount, and then we'll use the copy command to recursively copy all the files from the floppy disk onto the new hard disk. So you'll see that the files can be copied. And then hopefully I'll finish the copy and I'll just run the find command to show you that all those files are there. Okay, that's finished. We can now make the disk bootable by writing a startup program to the boot block. Have a look at the root file system of the floppy. So we're going to mount the std0 partition onto the DA file system. Make sure the pause mode is off. And we're going to cp tree -force time verbose from slash onto /da. So we're going to copy everything from the floppy onto the /da mounted file system, which is the hard drive. The first file it copied was chromix.sys, which is the operating system. It's now going to copy the bin directory, the binaries directory. We'll pick it up at the end of this copy. Okay, that's completed. Less minus L of /da. So you can see that's the contents of the DA directory, which is now bootable as well. That's a partition is bootable. If I do find into /DA and -print, we will see all the files yet again. But this is from the hard drive, so it should be a bit quicker. What a wonderful sight. Finished by TSTD0. So this disk is now fully prepared for anyone with a Krememco system. It contains Chromix 168. It's bootable on a 68,000 processor system. Alternatively, it could be reformatted for any vintage computer system of the day that needs an MFM hard drive, and you'd have to do your own alternate track formatting, of course. Okay, Dari, that is it for now. We're going to shut down. One last thing, we'll do a power down of the hard drive, then we'll start it up so you can hear the hard drive start up and shut down to make sure it's entirely to one's satisfaction. So 1 second. Three, two, one, off. Okay, wait 5 seconds. 1, 2, 3, 4, 5. And that is, as they say, a wrap.